everyone, and welcome to the Introduction to Scaffold ETH workshop. Joining us today is Kevin Jones, who will be taking us through this session. And with that, I'll pass it over to Kevin to get the session started.
Thank you so much, Rory. Appreciate it. Thanks for joining, guys. Super awesome to see everyone here. I'm really excited. It's been about, I think this time last year, I was speaking at the other Scaling Ethereum. And so it's really cool. It's really excited to be back. My name is Kevin Jones. I am a developer advocate for Scaffold ETH, all about trying to help developers coming into Ethereum and specifically coming into the ETH Global Hackathon, how they can use Scaffold ETH as this kind of tool, this catalyst to really kind of kickstart your project and get you up and running really quickly. So without further ado, let's go ahead and just start sharing your screen. Let's just go ahead and dive into it. So first of all, I wanted to just kind of talk a little bit about how you can find Scaffold ETH. So if you're at home and you want to search for it, you can just do a simple Google search, and you're basically going to be able to just click the first link, and that's going to give you the GitHub repository. So to get started, just search for this. You can clone the repository. So you do need a couple things installed on your system. You need Node.js installed. Obviously, you need to clone the repo, so you're going to need Git. It's going to basically install everything for you. And this kind of like quick README is going to like get you up and running. But I'm going to go through it with you guys today, and we're going to kind of tinker around and show how Scaffold ETH is going to kind of just help you kickstart your Ethereum project or your hackathon project. So one of the things I want to talk about too is also after you're all done with the hackathon project and you guys want to learn more, check out speedrunethereum.com. Quick shell on this. This is a kind of a step-by-step validation of your skills where you can go through some challenges. You can build a NFT, build a staking app, build a token vendor, and then eventually you actually get invited to what's called the Build Guild. And I just want to briefly touch on it, but the Build Guild is a group of developers like myself who are trying to help the Ethereum ecosystem, specifically that kind of using Scaffold ETH as this kind of like public good to help build your applications, your decentralized applications. And eventually you can actually become part of the Build Guild. So check that out. That's a good path. So I've gone ahead and I've actually already checked out the repository. So I'm using Tmux. If you guys aren't familiar with Tmux, it's basically a terminal with Plexer. Allows you to have lots of windows up. You always need like kind of 3 windows up to get started with Scaffold ETH. So I like to use it. It just makes things a little bit cleaner. As I was saying before, I've already gone ahead and checked out the repository. I've also gone ahead and did the yarn install. So if you do yarn or yarn install, it's going to install all the dependencies. So you'll check out the repository, do a yarn install. Yarn install is going to install all the dependencies for you. And then you can get up and running with a blockchain using yarn chain. That's going to actually spin up a copy of hard hat running locally on your machine. You're up and running, ready to go. So, and it's also going to come with these 19 or actually 20 accounts that have some play ether in there that you can kind of start toying around and kind of test your assumptions as you start to build your application. All locally. Then you're going to open up a new window. So again, you can do this new window. I'm just going to tab over this one and I'm going to do a yarn start. Okay. So yarn start is going to do exactly that. It's going to spin up a copy of React. So it's equivalent to doing the React start of the web application. It takes a second for that to start. So we'll go ahead and let that sit. And we can see after it started successfully, we can also see that we have some contract calls that are being made that are being outputted to hard hat as well. Then in this last window, so you're always going to kind of keep those 2 windows up. Your back end, which is hard hat, you got your front end, which is React. And then here is where you do your deploy. So the last step is we just do a deploy. We do a yarn deploy. It's going to take a contract that comes to Scaffold ETH and it's going to automatically deploy it to hard hat for you. And it's going to show you here that it was successful. It's going to show you what the address was. It's going to show you how much gas was used. And if you wanted to get a new version, you could just do yarn deploy -- reset, and that would force a deploy and it would give you a whole new contract. Okay, so we can see that everything's kind of working. We can go through and do these deploys as many as we want. So we're going to keep getting instances of our contract. And then we can also check out the UI while we're here. So Scaffold ETH, again, it runs in React. It runs on localhost port 3000. So you can see here that we're up and running and we have this kind of like UI, which allows us to kind of like start tinkering with the smart contract. The first thing I want to show you is there's some tabs here with a lot of different stuff going on. This first tab is kind of just like a place where you would build your application. So if you're building your project, you're going to go into the packages, React app folder, source folder, views, and then home.jsx. And that's where you can start building your dApp. right, inside of Scaffold. You can kind of think of it as just this as an app, dApp within a dApp, and it's just gonna build out inside there. So that just shows you how you can kind of get started. But really what's awesome about Scaffold ETH is it has this debug contracts folder. So we can see here that we already got a contract that's been deployed, and we can see that it has an address. We can see that it has a variable called purpose with a value of building unstoppable apps. And then we can also see we have a function that allows us to update that. So let's take a look at what that smart contract looks like. So I'm going to load up VS Code. And if you're using VS Code, you can simply just go to the packages folder here on the left, and then you can go to either Hardhat, or you can go to React app if you want to toy with the backend. We're going to start out with Hardhat, and we're going to go into the contracts folder, and we're going to go into your contract. So like I said, it comes with this a contract which has been deployed, and it's very simple. It's just a string. So we could change that string here if we want. We could say building awesome apps or something like that, right? We could save that. We could come over here and we could redeploy again. Okay, and then after we do that deploy, there we go. We get that kind of automatically updated in our front end. And so again, this is going to take that existing contract, and then you can start kind of building off of that and then build your apps. We can see here that we have the function, and then we have a constructor that's empty, so we could do something there. So let's kind of like start tinkering in a little bit. Let's create a new variable. First of all, let's make it an address variable, and we're going to make it a payable address, and we're going to make it address public. We'll do public payable. I think that's equals, and then let's grab our address. So the next thing you'll know with Scaffold ETH is you have this ability to basically get a copy of a private key that's automatically generated inside of your browser. It's called a burner wallet. So you could click here and click connect and actually connect to MetaMask. But for the purpose of this, we don't really need to do that. What we can do is we can just use the contract address that we have that's already here. So here we have essentially a burner wallet that's already there, and then you can kind of also see that there is a little bit of a block key that's generated, and we can see if it has a balance. We can also click the little wallet, and we can send funds around in here. We can also take a look at the private key if we wanted to, right? So there's a bunch of different things you can do. And then on top of that, we can essentially use that variable, okay? So what I want to do first is, let's say that we want to hard code an address, right? We could do that. We can hard code it in here like I was going to do. Another option that we can do is we can create an owner variable using the import command. Okay, so we can import ownable here. We can save that, and then we can redeploy. So and we also need to say your contract is ownable like this. Okay, so now let's go ahead and deploy that change. So now let's take a look at our UI. So what's happened? Well, we automatically got a owner variable that showed up here. Okay, more specifically, what's interesting about this is we are inheriting. So the idea of inheriting another smart contract is here we can inherit that contract, and then we can use that inherited contract as an inherited set of values. So we get all of the functions and all of the variables, all of the modifiers that are essentially available in there. So now we automatically have access to a owner variable, which I was going to hard code, but the better way to do it is actually use ownable. Now, this is a hardhat address. So again, Scaffold ETH uses hardhat. So the next thing we'd want to understand is how does Scaffold ETH deploy the actual code, or using hardhat, how does it deploy the code? So let's go into our hardhat folder again, and right below you'll see that there's a deploy folder, okay? So we can go to the deploy folder, and then we can come here and we can take a look at what's going on with the deploy. So here we can see that we get a full list of the named accounts. And so in this case, we have the deployer, and we get the very first address, and then we use that to deploy our smart contract. And then here, we use that deployer, and then we can also do things like if we wanted to, we could pass some arguments to the constructor here. Like if we wanted to name our token, or if we wanted to pass in some kind of like value like this, we could do that. We're not going to do that right now, but that's good to know that you could edit your deploy script here. But what's more importantly is because we inherited ownable, you'll notice that we got some new variables that showed up here, and we also got some functions that showed up here. And one of those is called transfer ownership. So that's part of ownable. Ownable is essentially a way for you to manage ownership, access control of your smart contract. And so now we have access to that here. So what we can do is we can call that transfer ownership inside of our deploy script. And so if we come down right here, we'll actually see that we have a kind of a grayed out version. So we can just copy that, and we can instead paste our address that we get here. Okay. And so again, this is a burner variable, a burner wallet, and it's inside of the browser. So the private key is stored inside the browser, and we have the public address, so we can transfer using that existing function, and we can pass in that burner wallet that we have. So we can save that, and then we can go ahead and redeploy. Okay, so let's take a look at the front end now. Now we can see that the owner is going to get updated. Let's go ahead and refresh. Oh, did I pass it right properly? Let's see, make sure I did it properly. See what I did wrong. Your contract is not defined. That's interesting. Is it spelled differently? Your contract. Transfer ownership. That should work. Looks like there's kind of that bug with the name of the contract. Let's see. Oh, your contract. Yeah, that should be right.
There was a comment that says uncomment the line.
Let's see here.
Above the transfer ownership.
Above transfer ownership. No, this is part of the thing. I don't think it needs to be uncommented, actually. Oh, I see. We're not actually getting your copy. Yeah, you're right. Thank you. They changed this.
Thanks, Philip.
Yeah, appreciate that. So here we actually get a copy of the contract. I thought we were doing that already. So I think we need to do it like that. But oh, that's if you just want to get access to a specific contract. Oh, here it is. I see where it is. So they changed this. Sorry, guys. This is throwing me for a loop. Yeah, so I need to actually grab it here. There we go. Let's try that. There we go. Thank you, guys. All right. They changed the deploy script recently, so that's why I didn't notice it. Okay, so now we can see that we've moved ahead. So this is good. We did some real troubleshooting, and what we had to do is, let me just show you what we had to do. So we actually had to get a copy of the instance of the contract before this was automatically put for us, because during the deploy, we would automatically get it. But since we didn't do that, we're creating a variable here, and then we're using ethers.getContract. We're using your contract as the name, and then we're using deployer, which is actually up here, which is the named account, right? And then here, we're actually calling that transfer ownership function. Okay, so we got that. So, so this is interesting. So now what we can do is we can start thinking about, okay, well, like, let's say we want to actually make changes to our smart contract, where instead of like someone who wants to call a specific function, maybe we want to require that they pay some value. So I'm going to show you here how we might do something like that. So first, let's go ahead and create a uint, and we're going to make it publicly available. We're going to call it price, and we're going to make it 0.01 ether, like this. Actually, we're going to go 0.01 ether, like that. And then we're going to say that we're going to do a require statement. So we're going to say, all right, so make sure that the message.value that's being sent equal to price. Otherwise, send no money, like that. And then we're going to close that off. Okay. So now what we can do is we can redeploy. And again, so what we're doing here is we're just basically creating a variable that is a certain value. So we're defining it in ether. And then we're also requiring that anyone who calls this set purpose, instead of just calling it, they also have to send in some value. Now it is already payable. You want to make sure that your function is payable, which it already is. And so now what we can do is we can come over here and try to set the purpose to something new using the function. So we can say like scale Ethereum like this, and hit send. And if we don't, it's going to send more money, right? We need to send some value in the contract. So we don't have any funds. So how do we get funds? Well, we can just click this little button right here, and that's going to give us 0.01 Ether from the burner wallets that come with Hard Hat, or I should say the deployer accounts, and it's going to put it into our burner wallet. We could get more as well. So we could click the address here. We could come down here, click the address for this kind of like dispenser, and we could get, I don't know, let's say we want $100 worth of Ether. And then that will transfer from Hard Hat as well. And now we have 0.06 ETH, which is $117. And so now we have some ETH to play with. So let's go ahead and do that. So we're going to go 0.001. And then what you'll notice is you'd think you could just put that in and you can hit send, but that's not going to work because you need to actually convert that value into Wei. And so there's this awesome button right here that does that for you. It's going to multiply your value times 10 to the 18th power, which is how you convert from Wei to ETH. And so that's going to tell us exactly how much Wei that we need to send in that transaction. And then we can click send. There we go. Now it was successful. So we're able to update the purpose because we are a specific, sending in a specific value. And then we can also see that our contract starts to get some value. Okay. So we can actually start using the contract as a bank. And so the next thing you might want to do is like, okay, well, let's create a withdraw function, right? Like, let's do that next. So let's say function, sorry, I cannot type today for some reason, function withdraw, and we will send, we don't need to send anything in that, but we're going to make it publicly available, and we'll get back to that in a second, but we're going to require this one to actually, we're going to just do like this. So let's do set a boolean called success, otherwise we won't set a value. And we're going to do a message.sender.call, which is how we can transfer value from the contract to the address that we're calling. And we're going to pass in a value of the balance of this contract. So we're going to say address of this contract's balance, like this, and then we're going to close that off. Now, we wouldn't want anyone to be able to access all of the funds that's in the contract. So this is a good example of how you can use Ownable. And you get access to also what's called modifiers. So Ownable has modifiers for only owner. So we can say that, only owner here. And so this is going to require that anyone who calls this function is the owner of the actual smart contract. So we can hit save, and then let's go ahead and redeploy again. Did I spell something wrong again? Probably. Oh, I need to make it payable. Let's do that, I think. No, let's see. I think I'm spelling something wrong. Sorry. A little, oh, I think we need to put that this to the end. Sorry. Try it again. There we go. Okay. So now we've successfully been able to deploy our contract. So now I want to talk a little bit about the burner wallets again. I'm going to open up a new tab here. And I'm sorry, I'm going to open up a new incognito tab. Sorry, file new incognito window. And I'm going to go to localhost 3000. So we can see now that we have a new instance of our burner wallet. Now, here we have like this kind of like purple, green, blocky dude. Here we have like a yellow and green blocky dude. So we can come over here and we can get some funds from the faucet. We can also grab some extra funds if we need to. So let's do that. So we have full control to access the faucet. Let's give $10,000 to this guy who's rich. And we can update the function. So let's say set purpose to scale Ethereum like this. And we can do 0.001 Ether. We can send that. And we're able to update it because we are this kind of like new user of the dApp. But if I want to come down here and then use the withdraw function and get this $1.75 of ETH or 0.001 ETH, and I want to hit that and I hit send, it's going to tell me that ownable caller is not the owner. So the ownable is basically blocking access to that deployment or to that function. But if I come over here and because this owner will match, then I can actually withdraw the funds. So here we go. And then there we go. I was able to take the $1.75 and put it into my wallet. So we've been able to utilize Ownable to do that and get going. So one thing I will say as well is that if you've got a hackathon project that you're working on right now, there are a lot of builds of Scaffold ETH that have kind of like good starting points for different things. So the one that I showed you guys is kind of like the basic kind of starting point, and then you can kind of start building out. If you want to, like, I don't know, let's say you're going to work on an NFT project. So if you go to the Scaffold ETH repository and then you go to Scaffold ETH examples, there is a complete list of a bunch of different examples. So you could seduce, start typing NFT here, and there's like a VRF NFT, there's an aging NFT, there's a Chainlink VRF NFT, there's a buyer mint NFT, which is quite interesting, which allows you to basically mint NFTs, and the buyer has to pay the minting fee. And so there's all these different kind of starting points that you can use. And there's also like an 1155 version that allows you to do SVG examples. So there's all sorts of examples there. There's also some examples in the challenges folder. And there's also some examples in the Scaffold ETH folder. So you can kind of like dig around. So if you have like an idea in mind, make sure that you're using one of those kind of like good starting points as your starting point, so that you don't have to write a certain amount of code, right? It's going to kind of get you up and running. And then if you're kind of just messing around, I also recommend, like, if you're new to building on Ethereum, check out Solidity by Example. Solidity by Example is going to have like a bunch of examples, and you can kind of do things very simply, like creating if-else statement, or getting the gas price, or converting, or how to convert Ether and Way and use different values inside your smart contract. Whatever it is you're messing with, you can come here and kind of see examples. And another reason that it's useful is a lot of the code is explained on YouTube as well. So if you're one of those people that's more of a visual learner, you can go there and you can kind of like watch the video, grab the syntax, put it into Scaffold ETH, and kind of toy around with it as a good starting point. And yeah, so I hope that's valuable. I want to save some time for questions. So if anyone has questions about how Scaffold ETH works, or if there's something that I didn't cover, please let me know. I'm ready to help you guys out.
There was a question early on what exactly is a burner wallet, and another participant commented, but I wonder if you wanted to maybe share your...
Yeah, absolutely. Yeah. So again, just to refresh on that. So you could, if you wanted to, use MetaMask. So you could click connect and you could use MetaMask. It's going to give you like an error. Like in this case, I've already selected, so it's going to tell me I need to switch to localhost, so I can do that. Actually, I might have to do it here. Let's do that. It's localhost. There we go. Okay, they changed the chain ID on me as well, so I need to go in there and edit my chain ID. But yeah, it's kind of a hassle to deal with MetaMask for a couple reasons. One main reason is the nonce issue. So there's this one issue with nonces where MetaMask will start building up like the nonces, and eventually your dApp and your MetaMask are kind of out of sync, and you'll start getting nonce errors. And so that can be kind of annoying. So that's why I recommend just using the burner wallet. So disconnect MetaMask and just use these wallets, especially if you're on like localhost, because it's really just easier for you to do your testing, and you don't have to worry about like loss of funds, because it's all just kind of like hard hat money. When you get to like a testnet and you start to deploy to Goerli or some other testnet, you'll probably want to start using MetaMask, and then you won't have to worry about the nonce issue, because you won't have this issue where like the deployments change and your MetaMask doesn't see that change, and there's this kind of out of sync problem. So for testnets, you can use MetaMask. For localhost, just use burner wallets. It's just a little bit easier. And again, the burner wallet is just all inside the wallet. And so if you were to open up a new incognito window, you could have as many kind of identities as you wanted to, because these, I'm sorry, I lied to you. In this case, we have the incognitos are kind of working as one instance here. So you can have like multiple kind of instances of wallets, and it just helps you kind of like test your assumptions.
Cheers, thank you.
Mm-hmm.
Oh, there's another question. My team wants to know if Scaffold is enough to work with multiple wallet solutions as show, or should we install used dApp?
Yeah, I mean, you could use like, you're talking about like here, I assume you can use like Wallet Connect. You can use, I don't know why that is some kind of modal error that's having lots of errors today. It's been a while since I did this demo. So yeah, so I would probably say that's fine. You don't need to use any kind of other solution. You can just use everything that comes with Scaffold ETH, and it should be good. Of course, you could kind of like add your own components. Like if you wanted to use, a different kind of identity provider or connector, you could, but you don't need to.
And does Scaffold work with MetaMask on ZK EVM chains?
Yeah, I believe it. Yeah, it does. Yeah, so it should work. Yeah, as long as it's like EVM compatible, it will work. I particularly haven't really tested it myself, but I'm pretty sure it works.
And Steve made a comment. There's one branch of Scaffold that I wanted to use which doesn't work. Chakra UI.
Yeah, I've never used the Chakra UI one particularly. I would probably say you could utilize just the base version of Scaffold ETH, and then because it's using React, you could just add in all of the Chakra UI stuff on your own. It's pretty easy if you just go to like Chakra. I've used Chakra UI before. I've never used the Chakra UI version of Scaffold ETH, but you probably can just import all that stuff manually using the Chakra UI, kind of getting started. There's like different ways to do it. You just put it in your React code, which I didn't really get to too much, but there is an entire folder here under React app. And then inside React app is the source folder. And you'll see there's an app.jsx file. And so this is kind of like the starting point. And I didn't really go too much into React. I was kind of just focusing on Solidity. But this has a lot of information here in the comments to get you started, like how you adjust your networks. But you could, again, add Chakra UI probably pretty easily here into the base application, and it should work without a problem.
And Wilman asked, when Scaffold ETH version 2?
Yeah. I didn't really get to that too much either as well, but if you do a search for Scaffold ETH, or actually if you go to like the GitHub repository, there's an SE2 branch. So if you do SE-2, it's currently in a working condition. It totally works. So it's Scaffold ETH /SE-2, and it's basically just a rewrite of Scaffold ETH. Most importantly, it's using Next.js instead of React.js out of the box. It's using Rainbow Kit. It's still using Hardhat, but it's also using WAGMI, and it's using TypeScript. So if you are more familiar with Next.js or with TypeScript, this might be a good option for you to start. But just know that if you're using it for your hackathon project, it might be a little buggy. There might be some issues. So it's not fully ready yet. Unfortunately, I don't know because I'm not particularly the one working on it. I don't know when it's going to be completely 100% ready to replace Scaffold ETH, but it's definitely in a really good starting point. So if you want to toy around with it, I would recommend checking it out.
And that's all we have for questions right now, unless people, if you want to, we still have some time. So if you want to take yourself off mute and ask a question, feel free to do so. And if not, we can go.
Okay.
Oh,
Yeah, yes. Yeah. So let's say, never mind. My question is like ZK stuff integration, like in terms of like, let's say, I don't know if you guys have like worked with like Snacky.js or something like that generates proofs and like deploy contracts. In that nature, it's like I'm trying to see if like Scaffold here if has like any like Zoka trees like stuff examples or
yeah. So I particularly haven't messed too much with the ZK sync builds, but there are a couple here that I just saw, like ZK sync NFT, ZK sync starter kit. I think mostly everything that we've done is around ZK sync. So you might want to check those out. You also might want to look on like YouTube and see if like Austin Griffith, who's the creator of Scaffold ETH, or anyone else has done some stuff with ZKs with Scaffold ETH. I'm not familiar particularly, but that might be a good option as well. I'm just going to check this branch real quick. Okay, so there's also some on the Scaffold ETH examples folder, like ZK committable NFT, game example, proof membership, voting example. So there's some stuff out here. And usually like this one is a voting example, right? And it has some additional documentation. So you can go through and see whoever created this build, hopefully has done their due diligence and created a decent README for you to at least to like look at and understand what's going on. But if not, and you have questions about it, you could look and see like who committed the code. You could try to reach out to them. You could also check Scaffold ETH. If you have problems, you can go to the Scaffold ETH Telegram channel and you can ask in there to see if anyone has examples of stuff they've done with Zcades on Scaffold ETH. That would be another good option. So if you want to get onto the Telegram, which is also something I would recommend everyone do, you can go to Scaffold ETH and you can go all the way to the bottom and there's a support chat right here. You can click that and you can join the Telegram group. And if there's something I wasn't able to answer, or someone wants to get more help during the hackathon, that's another good spot for you guys to go.
Yeah, thank you so much. Like, this is so helpful because they have like some stuff that I was actually working on. Cool.
Awesome.
Yeah, thanks.
There we go. Yeah. Well, thank you so much, guys. So again, go to Scaffold ETH, check it out, check out the repository, get up and running, check out the support chat. And yeah, if you're all done, don't forget to speedrunethereum.com to check out that as well. So I appreciate it, guys.
Cheers. Thank you. Well, thanks everybody for joining. And thank you, Kevin, for the great presentation. And yeah, cheers. Well, have a good rest of the day and happy hacking.